computer. All right, so we're having a quick conversation today in regards to the first iteration of the reference architecture for the Cloud Native at 50K. This architecture is intended to be the use of the Helm charts with Kubernetes, and then also have some components specifically regarding state stored outside of Kubernetes, and all of this integrated. Grant, can you give me a rundown of the progress you've made so far? I know we have some notes inside of GitLab org quality performance issue number 145, but just for the record, you can summarize that.
Well, I guess none. in an essence, basically what I've been doing for the last few days is going down some good, but some of the wrong paths on how to tackle this, just due to misunderstandings about what this task was. There's been a lot of progress in reminding me relearning Kubernetes and all of its quirks and how to kind of achieve with it. But the actual overall solution is well, kind of going back to square one. But that's fine. Square one isn't back to zero. Square one is that the vast majority of the environment is already running. It's just literally me now just trying to figure out how to set up the web nodes, the Rails, and the Sidekick nodes, as well as the load balancing for them, which comes with Kubernetes, and then correctly hooking them up to the backend services. So it's just figuring out how to do that with the Helm charts. So that's where we are at the moment.
Okay. So I guess the only immediate question that I have is have you considered whether you want to have the web and Sidekick inside of the same Kubernetes cluster, or even whether they should be on separated pools in the same cluster, or do you really want to go completely separated clusters for any reason?
On the path that I was going until yesterday, they were going to be on the same cluster but different node pools. I looked at literature online about separating clusters, and it seems a bit, for what we need, we don't need it. But if there is another argument, then again, it's not that wouldn't be too much of a change. But certainly clusters seem to be quite capable these days, so the different node pools of GCP would have been enough.
No, I agree. It was more of an exploratory question
Yeah, no,
than
it's fair.
anything else. So we're looking at using Postgres outside, right?
Yep.
Through Omnibus, or are we looking at Cloud SQL for this exploration?
It will be Omnibus to start with. It's one of the quick questions I did have was it's going to be Omnibus to start with, because this is being driven by a customer's requirements, and it sounds like they're going to go with Omnibus. However, if we have time, or in the future, it would be certainly interesting to explore a cloud service. In terms of performance testing, I guess the goal there is just to validate that it can handle load. In theory, it should. Else, what are these cloud providers doing, I suppose? But the problem comes in that we will test at Google's cloud service. We could do AWS, but then we're not able to validate others. So that opens that door. But nonetheless, some customers will come to us and ask to use that. So we will eventually to validate, but we'll probably stick with Omnibus now, since we actually control that.
Right, especially when it comes to those state systems, right?
Yeah, all the state systems will be we will be using cloud object storage. That will be that's the current reference of our environments already use those. They use it on Google Cloud. I think there's like one actual small teeny bit that is using NFS, and that's purely because the config there isn't automatable. It's a manual UI step, so we've just not done it. I will need to check if we've actually raised an issue for that. Hopefully we can get that automatable with a config settings instead of a UI thing. So the vast majority is using cloud storage, except for obviously for pages. So that will be maybe one of the more problematic areas that we need to explore. But yeah.
For cross-reference to others, GitLab org charts GitLab issue number 37 relates to the support of pages within the Helm charts. Currently, this is an upstream issue. We're awaiting changes to pages. This work is in progress, but we have to get to the point where Pages doesn't require a shared file system between all Pages nodes, and you don't have Sidekick that actually has to have a job that writes to that file system so that Pages can consume. Um, I have to check on the progress there, but it remains an upstream issue for the time being. There
Yeah, I
is a
don't
way
think.
to do it in combination with the Omnibus and some separation of Sidekick queues and a couple of things to really separate those out. Uh, but as for now, that's not native to the Helm charts for
No.
good reason.
Yeah, no, I agree. Pages will just wait until the actual product's updated. I think that's probably for the best.
Yeah, it's actually not that complicated to do, believe it or not.
Okay.
Um, Effectively, you separate out a single Sidekick queue. So you
Yep.
have a Sidekick cluster that has one queue configured,
Yeah.
which is the Page's job. That's
Yep.
it. And then you configure the Sidekick pools inside of the Helm chart to just not include Pages. So the only place that the Pages jobs get run are on the Sidekick node or nodes outside that have Pages on it.
Mm.
In my test environment when I did this work, I effectively had everything in a K3s cluster and then a VM right beside it that was running Omnibus with Sidekick on the same node as Pages. So in theory, you could have that dedicated Sidekick job actually talking and doing the writing there. But I would probably have just one or two small nodes doing the work. That task is actually pretty small.
Yeah,
Um,
that's
it's
fine.
it's pretty much pull the artifact and unzip the artifact.
Yeah, yeah, I understand what you're doing with that. That makes sense. For customers that really need pages, that would probably be explored, I guess, today, and hopefully pages will be updated uh, soon to do that natively. But yeah, that's not it's not actually that bad of a sidestep then. Yeah, as you say.
Yeah, it's not that complicated. Um, Basically, at this point, the only thing not present is like the actual setting of the page's value
Mm,
inside of the Helm charts. Issue 37 has the trace and information of what needs to be changed to make that work. We do have sidekick negation in play, so the similar to the way the sidekick cluster has that ability. So it's
okay.
functional, but it needs explored and documented before we go really playing with it.
Yeah, no, agreed. That seems fair. Yeah, the goal behind this kind of general task is to kind of give a recommendation. Um,
Mm-hmm.
I've always said since the beginning, since the start of this work, and from a previous experience as well, a recommendation is just that. It is the recommended kind of a place to start. Every customer will have their own requirements and tweaks and things they'll need to do. So I expect most customers' environments will look like the recommended environment, but with extra tweaks or things relevant to their requirements. So when it comes to pages, we probably won't cover that in this work, but at the moment, if a customer really does want it, then that's probably a task with support to kind of guide them through how to do that themselves,
Right.
or their representative, whoever that is.
Mm-hmm. And really, it's a documentation matter at this point. So
It
okay.
is, yeah, yeah,
All right. So let's talk about what you have done in Kubernetes so far.
yeah.
And you said that you had one cluster with multiple pools, so you had one doing API and one doing Sidekick.
Uh, one doing. So for the reference architectures, we have just the Rails nodes. So they're doing
Mm-hmm.
all the web stuff in multiple nodes, although those nodes are essentially identical. So that was API Web uh, and Workhorse, and I suppose SSH um, into each node. That was just based on previous work that others have done to do it. So the work I was doing was kind of tackling this the wrong way, in that we were taking on an Omnibus environment that we've already done and validated and verified, and we were going to just try. My understanding was I was just going to try and switch a few things out with Kubernetes. So I was kind of taking that omnibus approach, whereas from discussions with yourself yesterday and kind of reading more, that was obviously Kubernetes isn't easy, and trying to do something quickly isn't the way to go. So the right approach would be the other way around, which is use the Helm charts to build out the Omnibus to build the Rails nodes and the Psychic nodes, and then use Omnibus to plug in the gaps in the background that aren't so suited to Kubernetes. So the progress was that yesterday the progress was that I simply was able to get up a pool of GitLab's Rails nodes that were able to talk to the backend nodes, but that was using the Omnibus Docker, switching everything off in it and just setting up the Rails pieces that we need, and so figuring out how to make sure the file system permissions are correct and the network is able to communicate. Just working through that, and then having a simple load balancer front, and then the idea was to iterate on that and use a better load balancer ingress, and then eventually when the Psychic nodes in as well, they were still in the back end. I was just doing it piecemeal.
Mhm.
But the approach today would be to, I guess it is still kind of the similar thing of doing that, but taking the first approach of let's use the Helm charts for Unicorn and Psychic and get them correctly communicating with the backend nodes themselves.
Right. So for context, the problem with using the Omnibus is not that it doesn't work. Understand that.
No. I appreciate that. Yeah.
It's actually it's very heavy because it contains everything. It's the nature of being an omnibus that literally means I have everything.
Yep.
Its minimum startup time is well outside the bounds of most default liveness and readiness checks. You basically, the container has to start up, it sets permissions, it then runs reconfigure, it tries to configure, and then it tries to start everything that you just had configured. Configuring this is relatively easy because it's very familiar if you've done a lot of omnibus work. It's literally the exact same file. You just turn a bunch of options off and turn a few options on. However, if 3 of these things try to start on one node, resource contention really, really fast. Because the sheer amount of things that it's trying to start up and configure, and even with like high CPU nodes and single core, if you can get peak, it's still a slow process, right? And on top of that, should worst case you not have something that prevents it from coming up prior to its dependencies being prepared, so you try to start a Rails worker before the database is responding or the scheme is up to the date that it needs, it's going to restart. And unfortunately, it's going to do it immediately. So if you have one trying to start on a node and it gets most of the way up, Kubernetes goes, okay, well, that seems to be working. We're going to start another one. And then both of these blip out because they've crashed. Then you've now got into the fight of how many tries does it take before it comes all the way up. And now you're just eating CPU and churning. And you can actually starve other processes completely out of a node just because the omnibus is so big and trying to do so much. With the cloud native containers, which is what's deployed by the Helm charts, we've actually done some work to try and smooth all of that process out. So we've made it so it's just the Rails. It's effectively an installation from source. This does mean the configuration is a little bit different, but the primary behaviors are very, very similar. The containers, however, they start up, and one of the first things they do before they pass the init stage is actually check to make sure that it can reach Redis, that it can reach the database. Obviously, it's more transient if it can reach the object storage because it's an HTTPS API, so you just retry. Postgres, if you can't form a TCP socket connection, bad day. If your database, if you're trying to start an application from, say, today and your database is still from November of last year, you're actually going to have a big problem code base wise because of some possible changes to the data structures within Active Record. And we check for that one too. So that process will actually run and will wait and retry until the database comes up. And then it will start the process. So you know if it makes it into the primary one, the only thing that could actually make it stop is either a crash, a disconnection from one of the services, which could be Redis or Postgres, or an absolute misconfigure. And we try to catch absolute misconfigures through our templating patterns, but sometimes little things slip through. We've had people literally put the wrong URL in, and then nothing works correctly. Like that one I can't
Yeah,
fix.
that's all fair. I mean, obviously I didn't know that, but I knew from when you discussed it when you were talking about it yesterday, I knew it'd be something like that. And I know Omnibus is it's a it's a big it's a big package, and as you say, it has everything. And in Kubernetes world, that's not the right way, shall we say? And indeed, I was working about some timeouts, and I was just trying to literally recreate what we do in the reference architecture. So it's kind of tackling it wrong in the sense that I had nodes the same size as our Omnibus environments, and then deploying one pod to each, which isn't great. So no, that all makes sense. And if you got, well, yeah. So like I say, I mentioned this in the issue already, but like I said, yesterday I was under the wrong impression that Helm was just a complete all-in-one thing, and I couldn't use it. But now I actually realize it's a completely separate method to Omnibus. As you say, it's completely different from source, and it's essentially a different install method with different configuration, which is fine. That's not a problem. So that means that I can use those and use all the benefits that you guys have already tackled and try and design a reference architecture that's of a scale that can handle the performance we expect it to.
Okay, so let's have ourselves a look at what the. Do you have a like a drawing of any kind or a layout that I can use as a reference? We can share that drawing while we talk about it.
Yeah, maybe. Give me a second. We don't actually have drawings of the reference environments per se these days, although I can probably grab one that's pretty close to it if you give me a second. Like I say, this is all changed from yesterday, where I've only worked in this a few days, and the kind of the design of it was still very much up in the air, and had some general ideas, pencil drawings essentially, but I wouldn't have shared more until I actually had a more secure kind of uh, design. Okay,
Right.
let's use one of the existing drawings, which is fairly close to what the current environments look like today. Yeah, that's close enough. You want me to share my screen?
If you don't mind.
Sure. Oops. Get that sorted out. So, um, the joys of using a large monitor. So, if you actually go in here, this is actually the table of like one of the reference architectures. This is actually the
Okay.
base. It's the 10K environment. This one's actually to be 50K. That's because a customer of that scale is asking for it. But
Hmm.
the environments are scaled in such a way that it's the same kind of design. The only times they change is when you go really small and Redis drops down to just one node instead of multiple kind of paths, and Sentinels combined with console. But in the 10K kind of setup, everything's separated, and that's the way it is. So
Okay.
going back to that diagram, uh, this one here, this is fairly correct. As I say, right, console and Redis Sentinel are actually separated in a larger environment, but I think that's right. There might be something missing off the top of my head. Server Psychic, Postgres, Redis,
Right.
console. Yeah.
The biggest change is when Helm is involved when we're using the cloud native containers is that NFS goes away.
Yes, that's
Um,
shared storage is these images will be going soon. This page is about to get a refresh, but
mhm.
that should really now be object storage. We're
Right.
certainly we're pushing now, and an update will be clear that NFS is still an option, but it's the recommendation is to use object storage in Gitly where possible.
Right. Well, the thing is, this is the one that a lot of people seem to get caught on. Customers, engineers, don't worry about it. It's Gitly is in use at all times. It's there always.
Yep,
The application always speaks
it does.
over
Yeah.
gRPC to Gitly, and only in certain specific cases for specific users is there actually a code path where you can flip the setting to use rugged on local file systems via shared storage. We strongly recommend against doing that unless you have a very specific use case. And not only that, the Cloud Native charts thus only use Gitly. We actually completely disable the path that you can use rugged for shared storage, and that's on purpose, because it's easy enough to orchestrate an NFS for shared storage. Yes. It's not easy when the pod that is attempting to consume that is migrating between nodes, and now you have to worry about where is this NFS mounted, how many clients is it designed for, does it handle an unexpected disconnect, and when it reconnects on a different node, now it's different IP, blah, blah. It's just, NFS does work. We're not going to tell you how to do it because you don't want the headache. And if anybody else is watching this and has ever run an NFS server, imagine that guy with a laptop that's running around doing heavy NFS loads. And I mean, like, reading several thousand IOPS per second. That person with a laptop on flaky Wi-Fi, that is a pod in Kubernetes. Don't do it.
Yeah. No, I yeah, can add anything more to that. Yeah, NFS is very much unrecommended, but there's some cases where people will still want to use it. But yeah, so this is actually a more up to date drawing. We might actually add this to the page. But so the design of the Helm environment, as we'll now call it, to begin with, will be that services tier in this image will be replaced with Helm charts where appropriate. That are then configured to speak to the backends as shown there. So that's pretty much the difference. But the idea is obviously to use the Helm charts and configure those correctly and get everything happy and talking. The load balancer would also change to, in this case, GCP's or the ingress load balancer. So yeah.
Right. And sorry. For this reference architecture, we're primarily going to be working with the Nginx ingress and GCP's ingress directly to that. I should say IP direction right to that through layer 4. It is technically possible to put a layer 7 load balancer in front of Kubernetes clusters. It's definitely an advanced use case, and it can be explored for documentation, but I don't believe it's a goal for this at this time.
Yeah, that should be fine. With the reference environment, so Omnibus, we also had to set up a load balancer separately. There is Nginx in Omnibus for the GitLab nodes themselves, but to actually load balance those nodes, there needed to be another one. So for that one, we actually used HProxy just as a popular established load balancer, and that did give us a little bit extra functionality to do with health checks. But with Kubernetes, those are built in at the pod level, so that's not needed. So the ingress should be fine in theory.
Right. The biggest difference I know, at least at the .com scale and possibly in the 50K architecture, we do actually have some separation between web workers and API workers. So it's all Rails, but some paths are dedicated specifically for API and go to specific workers, as well as web going, okay, well, there's always going to be at least these 10 make responses. Things like this. That's a little more complicated to do inside of Kubernetes. It's doable, but I don't think that functionality is built into the chart right now.
Yeah, for the reference architectures, that was considered, but the 50K put was performing well enough where it was that we decided not to go down that path. But it is still a path for advanced cases where a customer is expecting, maybe they're expecting a heavy API traffic compared to web. And there'd be a benefit there to separate those out. Most customers we expect there to be a mix, but again, it comes down to that thing. These are just the bases you can tweak as you require.
Right.
Yeah.
And even if the thing is, 50K, we're still 1/10 the scale,
Yes,
right?
well, this is it.
That's a large part of it.
GitLab.com obviously needs every help it can get to be as performant as possible at the scale it is. It's
Right.
unlikely that one single customer would ever need to do that. But like I say, it is an option. For the Helm environments, I certainly would be looking to go down the same path of there's just Rails nodes and they can be scaled. And obviously with Kubernetes, you can automatically scale them as you see fit. If again that becomes a problem, then that would be we can iterate and then say, okay, there's nodes for API, nodes for web, SSH, that kind of thing.
Right. Well, SSH, that's actually already doable. So
So yeah.
unless you're using we have a way to use HTTPS for SSH, or I should say share the port. I don't know that that's actually doable in the charts. I've never tried it, and I'm not 100% sure how exactly we do it on .com. So it might be an HA proxy specific pattern.
Mm.
The way Nginx works is it doesn't identify the protocol. So if you say this is an HTTPS port, it's going to treat it like an HTTPS request, and it will drop anything that doesn't speak it, which
Yep.
SSH does not. So we'll have to figure that one out. But
Yeah.
most people are not using let's SSH over port 443.
No.
So this is not really that much of an issue.
No. I mean, that's one of the questions I did have. Is I did see there was a separate separate chart for the SSH traffic, but as I say, at the moment, I'm not for this scale. We're not expecting that to be separated. So I was wondering if the charts is Unicorn just Unicorn, or does it actually include SSH as well?
It's just Unicorn.
Okay.
So for every component that you want, you have to activate that section of the chart, which out of the box, you get the whole chart. And then we tell you, hey, for production, don't use our Postgres, configure one. Don't use our Redis, configure one. Don't use MinIO, configure real object storage. Otherwise, all components are turned on. By default, we do not turn on Grafana, but all operational components are turned on. So you have one for Sidekick, and then you can provide it a queues list, and it will create the necessary set of jobs and separate autoscalers for those so that you can actually individually manage each queue's number of pods and how many workers it's allowed to get to. Then you also have Unicorn, which Unicorn is, well, it's called Unicorn because currently it's the Unicorn process, which is GitLab Rails, which is the web and API service. We're in the process of implementing Puma. The functionality seems to primarily be there. We're working on figuring out the best way to make it a manageable chart in the future so that you can just flip between Unicorn and Puma back and forth. Because actually having separate charts that have 95% the same content is kind of a waste.
Yeah. Puma's, I believe, it's just gone actually live on GitLab.com today, 100%. So it's going to be the official web server, I think, sooner rather than later. The recommended one, even.
Right.
So it would be good to get that in. But Unicorn is also fine for now.
Mhm.
It is today still technically the recommended web server, so that's what we'll work with. Although the reference architectures are using Puma, but that was done in anticipation that Puma would already be here. But
Right.
it should be soon.
The good news is that the difference in configuration for the charts ideally is literally going to be gitlab.webservice.webserver
Yeah, it should be.
Puma or
Yeah.
Unicorn, and you just say which one you want, and then you say how many worker processes should I have and how many threads should I have. That configuration is identical between Unicorn and Puma. You literally just have to say the name.
You do, yeah. It's for the reference environments. I think it's 2 settings. I think it's just literally defining the number of workers and the number and the threads for Puma
Mm-hmm.
and the actual web server itself.
Right. It's
So
pretty straightforward.
yeah, it is thankfully. So yeah, for the Helm environment, it sounds like I will need to set up web Unicorn and SSH. What's the the minimum viable product, to use that term, of getting web nodes running in Helm? How many charts will I need to use, would you say?
To get web nodes to function in Helm, just the web nodes, you
Web nodes and
technically,
Sidekick, yeah.
web nodes and Sidekick, yeah, you only need Unicorn and Sidekick.
Okay,
It comes down to, are you splitting queues, or are you just saying, you know what, everybody run all the queues?
it'll be everybody run the queues for now.
Okay,
I think Sidekick queuing is a little bit involved. Again, that's an advanced use case.
right, right. I wasn't sure when it comes to the 50K reference where
It
that
seems fine.
metric started at.
Again, that's just at the moment it's just a GitLab.com
Mhm.
level feature. But again, if a customer really requires it, then that's something that can be discussed.
Right.
So yeah, I may have misunderstood the last answer then. So can the unicorn nodes handle shell requests?
No,
Okay,
the Unicorn pods only have Rails and Workhorse. The Sidekick pods only have Sidekick. Um, the shell's only job is, it's literally just a container that has OpenSSHD in it, configured the same way we do, effectively the same way we do inside of Omnibus, and they share host keys. So no matter which one you end up connecting to, just as you would with Omnibus, you've got one host key that matches everywhere. So every component is isolated within the charts. So if you just need web, that's what Unicorn does. If you just need jobs, that's what Sidekick does. If you need SSH, you can even, and I have demonstrated this, taken a chart, deployed just GitLab shell SSH, and an omnibus right beside it, and just turned SSH off on the box. People are like, wait, you can do that? I'm like, yeah, every single component can be turned on or off.
yeah. So it sounds like I'll need shell, Sidekick, and unicorn. Then is that the right understanding?
Yes. Yeah. So those are the three that you'll actually absolutely need. Where is the registry intended to be here?
Uh Register we've not really covered. Well, register was on the Rails nodes in the current reference environments.
Okay. Then my suggestion is to go ahead and also use the registry
Fine.
inside of Helm. Effectively, because we're already using object storage for it at the 50K reference size, and you can much more quickly scale the registry inside of Kubernetes than you can in Omnibus.
Makes sense. Yeah, no, I'm happy with that. Yeah. Because like I say, this is actually it's a even though not much is actually going to change, it is going to be a different kind of approach, a tone,
Mhm.
and that this is a Helm environment where with all the big backends separated, which are built with Omnibus just for convenience, but or could be switched to services. We'll see.
Mhm.
But anything that can be done today in Helm, easy, maybe the wrong term, but anything that can be done there, we will bring in, and that's fine
Right.
to Helm.
Okay. So I do see Console and Prometheus staying outside.
Yeah,
Um,
that's fine.
Grafana could possibly be included directly. Um,
Um,
that's an exploratory item. I'm just making comment.
yep.
Otherwise, Elasticsearch definitely has to remain outside.
Yep.
Uh,
We don't have those in the reference environments yet because it's not officially out, so to speak, even though it is a
okay.
little bit on GitLab.com. Once it is out, we'll probably add it to the reference architectures and then we'll add it to the Helm one as well. But yeah, as you say, I don't see. There's no way that that's going to be on Kubernetes because that's a heavy backend. So even though there's a front end component.
Well, I described this once to Sid when he asked, why don't we ship it as part of the charts? Um, Deploying Elasticsearch in full into Kubernetes is like deploying all of GitLab inside of
Yeah,
Kubernetes. It's not that it isn't possible, and I could technically integrate it as a part of the charts. However, it doubles the resource requirements. Uh,
yep,
and if in any way at all, we don't make that perfectly clear, with all kinds of like warnings and docs and a large number of things, it would be a very bad customer experience, which is why we still treat it as an external component that you happen to hook to, because you really don't want to have that fight.
No, I completely agree. You could if you're keen, you could deploy Kibana in Kubernetes because that is a web, that's the front end. But
Right.
Elasticsearch itself is a back end. It is the same in my head as Gitly, if not more, because the sheer amount of data that ES can store is incredible. So
Right. And in doing that in Kubernetes is doable the same way technically doing
GitLab is
Gitly
doable.
is
Yeah.
doable. It's just you have to have a lot of understanding of how the application behaves. And our Helm chart does its best to hide 90% of the complexity of how the GitLab chart behaves, how the application suite behaves. Um, the biggest thing I want to point out at this point, we basically know, what needs done, how it needs to be done, and we have documentation supporting most of this already. Um, Let me know if it's not discoverable, please, and we'll fix that.
Yeah, as part of this, I will be feeding back. So
Yeah, please.
yeah,
Uh,
I will if you don't worry.
yeah, and anybody else watching, please
Yep,
help me improve my docs. I try. There's a lot of information in there, and I know it can
there
be
is.
hard to consume. It's okay. Um, One thing I want to point out is that by default, the scaling configuration is meant for small instances, right?
Yep.
You cannot install a proof of concept deployment and then just go, okay, have fun, and watch it fall over when you push 5,000 users at it. It's designed for like 100 out of the box, and then when you want more, you need to do some preemptive scaling. Kubernetes is very automated. It's not black magic. If The nice thing is you don't have to run your infrastructure at 110% all the time for service peaks, but then it sits idle 90% of the time. But you still have to run it at least a significant portion above 5%, right? There's only so much scaling we can do in an instant. Just there's only so
No,
much
it's a fair shout.
scaling Kubernetes can do.
Yep.
So you have to preemptively say, if I want to have, 1,000 RPS to the web nodes, then I need to have enough to actually support that. So if I'm going to go from 0 RPS to 1,000 RPS, I need to have the ability to scale to that point before I fall over. If you go from 0 to 500 to 800 to 1,000 to 1,200, it will catch up. But you can't just go bam. You can't go from
No.
0% to 110%. It will fall over. And that is the nature of Kubernetes. You literally can't spawn that many processes that fast. This is the nature of it. So what you'll want to keep in mind is that you're going to want to set a minimum number of replicas for the horizontal pod autoscalers, the HPAs. You're going to want to set a minimum number and then set a maximum number. That
Yep.
is going to be based on, very similar to how we say how many Rails nodes that you would have and what their CPU cores are. The nodes that you have in the node pool for running the web API, etc., those nodes you should be pre-defining with so many CPU and so much memory. And then you should know how many requests per second you want each pod to be able to handle. So like by default, Unicorn has 2 worker processes and 2 pods. So that's 4 in total, right?
Yep.
So pod times process equals, right? So we had a customer in the past who were like, oh, well, we did this and it works great. But then we did it on the Helm chart and it exploded. Well, they had, they were running on a single Omnibus node, which is okay, cool. Can you tell me what the specs are? Turns out it was 64 cores with 256 gigs of RAM on rated NVMe. Um, That's a lot of horsepower.
It's
So by default, the Omnibus goes, oh, you have 64 cores. We're going to give you like 32 unicorn. They're always there. They're always sitting idle. So when they ran a load testing script against the APIs, that didn't have a problem keeping up because it had well over 32 processes running for Unicorn to be able to answer those requests. Whereas 32, 4.
yeah. That was actually
Problem.
one of my questions about the charts was that is it possible to scale vertically, horizontally, or both in with the pods and in terms of unicorn workers as well, CPU size as well as unicorn workers, or is it just horizontal in the sense that you just need to deploy more pods?
So technically, horizontal pod scaling is what we generally recommend,
Okay.
um, mostly because that's generally what you need is to just go sideways, make more of them so they can all answer and the load balancer can spread the traffic, right? However, it's entirely possible to say, I want each one to have 4 or even 8 worker processes. You need to make sure that the node can handle more than one pod at a time, because when you say I want this many CPU, it's going to allocate you dedicated X many CPU as a minimum,
Yeah, it is. Yeah.
right? Um, so
Well,
be
it's just
careful on
that
that one.
trying to mimic what we do with the reference architectures, the
Mhm.
idea was to size the nodes similar to what the actual individual nodes are in the Omnibus environments, and then deploy pods that would consume those.
Mhm.
With default GCP sizes, it gets a little bit sticky in the sense that you can't just say I want you can say I want custom CPUs, but it costs more. And generally, we've been pushing against it's been pushed against. We should just recommend standard sizing and to work with those pieces. So the
Right.
idea was, for example, for the 50K, at the moment on the page it says 15, but it's actually going to get scaled down probably to 10 after
Can
recent
you
testing.
switch to that for me?
Yep.
Thank you.
Um, so we say
Awesome.
15 here, but it's probably going to go back to 10. A separate task we're working on is to review our current CPU recommendations today. As it stands today, this was done basically 6 months ago. Generally, it was based on 6 months old work, and the scaling
Okay.
today is better because the performance is better, so it could actually get wave 10.
Okay.
So that'd be 10 nodes. So for example, the first iteration of this environment was going to be 10 32 CPU nodes in a cluster, and then deploying pods that request something similar to that. I've already been stung that you can't just ask it to obviously request 32 because each node is taking a little bit extra already. So it has to be 30. I understand that already. So, but again, we're stuck with the GCP standard sizing. So, fine.
That's okay.
But I was just wondering if the charts is it possible to do that because horizontally at 4 per node pod even, or 2 pods even is that's a lot of horizontal for 50K. We're talking hundreds, if not, yeah, hundreds.
Also, note that I'm not surprised. Okay, so if you've got a node that's 32 CPU and 30 gigs of memory, Unicorn runs at about 750 meg per process right now. It's not great.
It's higher
Um,
actually now. They
yeah,
raised it.
it varies.
Yeah, it does.
So basically what you do is you up your thread count, your process count in
Yep.
Unicorn. So you go from 2 processes to 4 processes, and if you double your process, you double your memory request. So you could probably fit 6 or 7 pods in here comfortably. It'd be close, but you could do it. Um, and Kubernetes will try not to make you go bonkers.
Yep.
But be careful. You can actually say, I want one gigantic pod that eats half of a node. You know, give it 15 CPU and 14 gigs of RAM. I don't suggest you do that because now you're actually fighting against the scalability and behavioral purposes of Kubernetes. You're,
No,
you're
that's the
basically
question. Yeah, that's my question is do I go big or do I go small and horizontal? So it sounds like horizontal is the way.
generally speaking, I would say horizontal, but don't be afraid to increase the individual size and reduce the total scale.
Okay.
So what you don't want is 16 massive pods.
Yep.
What you want is maybe a whole bunch of 4 or at most 8 process pods. Now, mind you, 8 process pods, that's 8 gigs each. So you're going to fit maybe 4 of them on an individual node. It's a little tight. So
That's
you
fine.
probably want to stay somewhere between 4 and 8, and then the memory scales with that. And as long as you set the reservations to match, everybody will be happy. Noting that you should leave a little bit of headroom for them to work inside of the excess, because we have certain things that spike the memory and then drop back out.
Yeah.
So in one regard, that's something there. The same thing happens with shell. Basically, you can say, I want 15 of these things, but with the nature of shell, the truth of the matter is, if you're expecting shell to be able to answer 1,000 requests per second over SSH, you should probably have like 100 of these things, or allow it to scale to that point. And the nice part is, it'll do it like that, because SSH starts up stupidly fast. You'll actually have more delay in the scale up from the platform that is Kubernetes than you will from the pod. When it comes from Unicorn, plan to be able to support 50% load at any given minute, which means set the minimums to 50% load requirement. Set the max to your 110% mark, and it will go up as load goes up.
Yep, makes sense. It's for our intents and purposes for performance testing, we need it to be ready for max, because that's where we test that for performance. So internally, the environments will behave a little bit differently, probably, but for customers, it makes sense to, as you say, aim for 50 and have it to auto scale.
Right. Well,
Yeah.
it's entirely possible to set the min and maximum pods on the autoscaler to the same number.
Yeah, that's probably
So
what
give me
what we're going
28
to do.
of these things. And by
Yeah,
the way, I only want to have 28.
yeah,
Okay.
very much. Yeah, it's a bit weird, but that's how it works. Okay, that's all been really helpful. The only other quick question I have is about console. I know in Omnibus, console is the kind of the background kind of guy that lets everything communicate with each other. I didn't see any reference to console in the documentation I've seen so far, so I don't
No.
know how that works. How the Unicorn Helm nodes could communicate with Redis in the background. There's
So
direct config there, I know, but was the console missing part there?
there is no console in the Helm charts. There's none
Okay.
at all. So what you would do is you would actually just configure them to the Redis node. And if that means that you need to tell them to go ask console for the node by DNS, you just point them at console's DNS naming. But we haven't actually tried using that. Right now, we actually say, okay, well, here's Sentinel, go talk to it. Whatever those host names are. And then Sentinel takes care of pointing out which one's master and everybody connects to the right place. When it comes to PostgreSQL, you point it at your PG bouncer.
Yep. Yeah, that's fine. Yeah.
Internally, Kubernetes already has a DNS implementation, so we don't have to rely on console at all. If you want to know how many web API nodes are there, you literally just ask the service for GitLab Unicorn. You go, hey, GitLab Unicorn, how many endpoints do you have? And he goes, okay. And it doesn't pick one to go to per se. It round robins. And you say, hey, Mr. Service, can you point me at one of your pods? It goes, cool, you talk to that one.
Yeah, that's fine. I get the we'll lose the Prometheus monitoring we get out of the box, which is fine. It wasn't designed to be able to handle this anyway, so that's okay. I'll figure
You mean
something
the
else
Prometheus
out.
monitoring between Omnibus and the Helm charts?
Yeah.
Okay, yeah. So we do have Prometheus that is capable of monitoring our charts.
Yep.
And of course, the Grafana that works on that one. We actually need dashboards that are more aligned because they don't behave the same way.
Yep. Okay, that's fine. That's something to figure out. We only need it for like light monitoring for performance testing internally. Externally for customers, that's they probably they could have their own. It depends on what monitoring service they want to use.
Mhm.
Prometheus is built in if they want to use it in Omnibus, but they might use third party or something else. So that's not so bad. But there's something I can maybe figure out to get that working correctly. But yeah.
Yeah, and believe it or not, GKE already has Prometheus deployed into it, and that's what GCP uses for monitoring.
Yeah.
So when you deploy it, there's already Prometheus exporters inside of the cluster, and
Okay.
then our entire chart has all of the exporters turned on for itself. So no matter where your Prometheus is, you can scrape it and get the answers that you need. So that's there. Let's see here. I'm going to take a quick look at this. So we have Sidekick. We're saying there's 4 nodes with 4 CPU, and this is more about 4 gigs per CPU, just based on node size.
Yep.
That's not a bad idea when it comes to Sidekick, based on the actual application's performance patterns. So out of the box, Sidekick comes with a HPA that has it set with a single pod that will scale from, I think, 1 to 3. At our load, we're obviously going to want that a little bit higher. Your architecture here is basically 4 by 4, so 16. So you would probably want that HPA to have 4 pods by default.
Yep.
And then it would
Makes
be a
sense.
matter of tweaking the queue, not the queues, the concurrency.
Yeah, that's fine. In this environment, the sidekicks would all be doing the same. The idea is just to have them spread out the load between them, so that should be fine to do. Sidekick, I'm not so worried about. Sidekick is quite performant, and it doesn't, as you say, doesn't need a massive amount of resource, so that's okay.
It does, but in very short
Comparatively,
spikes.
yes.
Right. Rails tends to be very heavy long term because it's active all the time.
Yeah.
Sidekick being the nature that it is, unless you get a massive influx on the queue, it's just gonna boop, 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 boop.
Yeah.
It's when, say, 5,000 users are importing 10,000 repositories, and it just goes smash.
That
Um,
would kill it. Yeah, I mean,
yeah,
that's
we've never
worst
seen
case
that in
scenario.
production.
Thankfully, that's hopefully an unlikely scenario, but yeah, Sidekick would certainly not be able to handle that well. Unfortunately, I'm going to have to go.
Mm-hmm.
I've got another meeting, but
Yep.
hopefully this is addressed any fears with what we're doing here. Admittedly, we're taking the wrong approach, but I'm going to take all this away and start building up a kind of a new design, which is going to be based on this environment here. But as I say, it's going to be using the Helm charts for the Rails, the Sidekick shell and registry, I guess, and scale those out in a good way that makes them performant while obviously not breaking any Kubernetes rules.
Right, and hopefully anybody who has questions about design or when or why and how we're doing it this way will have a lot of information from the call that we just had.
Hopefully so.
All right. So
Excellent.
thank you for your time.
Same to you. Thanks very much. Very helpful. All right then, better get going. Thanks again.